We're trying to figure out the range of this particular function, sine inverse of x minus root of x. So range pi by 2 is fixed. So maximum value is fixed, guys. So, I'm starting off with the shortcut version. Okay. So let me start off with that. So maximum value is fixed, and then we have minimum value to be 1 by 4 minus 1 by 4 and all of this. Okay. Now, so we know that range depends on the domain and the function itself. The function, we know that it is to be minus pi by 2 to plus pi by 2. So plus pi by 2 is fixed, so we don't have to bother with the maximum. We have to look at the minimum. Now, to look at the minimum, this expression has a root and all of that, right? So the graph, we need to go with the graph. Again, I'm using the shortcut method. So I'm looking at x minus root of x. I need to find the point of minimum. How can we find the point of minimum? Now it's time for you guys to pause and think. How do I find this? Yes, the answer is differentiation. Pause and think again. How can we make use of differentiation? Right, we just have to differentiate it. And when we equate it to 0, that's the point wherein the graph will change its path. So this will be 1 by 4, right? Root of x will be 1 by 2. Yeah, 1 by 4. So if that is the input, can I go with 1 by 4 directly? No, we need to substitute it over here. Therefore, we have 1 by 4 minus 1 by root of 4 is root of 4 is 2. Yeah, so this is basically minus 1 by 4. So answer is 1 by 4 is there. Okay, minus is over here. Answer is C. That's my shortcut version. Now I'll explain the shortcut version. Explaining the shortcut version. Okay. See, I am not looking at the maximum. I'm just looking at the minimum because maximum is fixed. I'm looking at the minimum. So minimum depends on, sine inverse of what expression it is. So I'm taking up the expression. I know that x minus root of x has a particular graph. Let me go with the graph. Again, all of this is something that you guys have to figure out in your mind, and you have to be that fast. There's no other option. So first thing first, we know that x is so, and root of x between 0 to 1, if this is 1, okay, the graph has to pass that point. So this is root of x. And so between 0 to 1, the graph has to go somewhat like this, and I guess it will something like that, right? So this is what I'm trying to figure out because that's your range. That's your range. And yeah, we know that maximum value that we can give to sine is 1 and all of that. But yeah, this is just x. Now we're looking at not exactly range actually. Technically it's range, but not the range of the question. Yeah, this is what we're looking at. And these two are helper graph. That's for understanding. So basically we are trying to figure out this minimum value. So what is the best tool to use? Differentiation, as simple as that. Okay. So let me make it very clear. Clarity is important. So what we are looking at is x. Just a second. Right? X. This is a x. First graph. Root of x. Second graph. So observe what happens between x and root of x. Okay. And now if I take the difference, obviously between 0 to 1, x is less than root of x. Right? It should be commonsensical to you guys. So this graph x minus root of x has to be negative. There's no other option. And we are trying to figure out this particular, the point wherein it kind of comes down and goes up. We're trying to figure out that. And that value happens to be 1 by 4 and 1 by 4, and that is 0.25. And you can see that it is, if I further zoom in, can you see that? 0.25. See the math, right? You guys should be going, wow. It is so. Maths is that good. Everything adds up. And with that knowledge, when I substitute and so on and so forth, I got the minimum value. And we have method 2 now. This is also quite short according to me. But yeah, I like this because it's kind of very short. So we have x minus root of x, right? We are trying to figure out the minimum maximum. We will use completing the square method, that is writing in this manner. All of this is not needed for you guys to be taught now, but I'm doing it. Completing the square method. So I'm trying to express this as a minus b the whole square. And actually a square minus b square, my bad. So that it's easier for us to calculate. Plus, okay, before plus, I need to write it as 1 by 2 because I took a 2. And now I'll be able to decide that this is 1 by 4 and minus 1 by 4. If you're not able to figure out, so we're looking at completing the square method. Completing the square method. Again, if you guys want to understand this, you guys can find it in 9th grade, or yeah, please learn this to understand this. So I'll end up writing this as root of x minus 1 by 2 the whole square minus 1 by 4. So when we solve this and all of that, we'll get the answer basically. Okay, so how do we do post this? See, maximum value is very clear. I'm trying to look at the minimum value. So to figure out the minimum value, 1 by 4 is a constant that we can't touch. This is where we can touch. And when will this be? Since it's a square, the minimum value is 0, right? So the entire expression has to be 0 as it's a square. Because it's a square, it has to be 0. When will this be 0? And this too leads to the same answer. Okay. Again, what did I do? I rewrote the expression, this particular expression, as a square minus b square. That we can do it with the help of completing the square method. This is actually checked. This is in 9th grade, was in 9th grade. They removed the syllabus. I just checked that actually. I think they removed. Yeah, they have removed. They have removed. Anyways, you guys can find this. Please learn that. And with that, with certain properties of root and square, you'll be able to figure out the answer. Right? Yeah.